Hi everyone, I'm going to go through a process called the guess method with you, which will allow us to be successful in solving any sort of mathematical equation. It will be beneficial for not only science class, but also for any math class or physics class or even chem class, things like that, that you have to use any problem solving method or equations. I used this in college, actually, in my physics class, and I didn't know it was the guess method. I didn't realize I was actually using the guess method at the time, but I use this same sort of setup to help me work through some extremely challenging problems. So this will help you for your future, I promise. The G stands for given. You are going to identify what are your known measurements at the beginning of the problem, um, including any value and units, and list them out for what specific variable they are associated with. We'll do some practice ones in a little bit so you can identify each of these steps in an actual word problem. But starting off with your known measurements with the values and units. U stands for unknown. So what measurement is it that you are trying to solve for in the actual problem? When you do this, I've identified that specific variable and then also include the specific unit that you think you're going to end up with in the end. If you can identify the ending unit as part of your solution right away, it helps you with the general setup, and kind of takes a little stress off your back in the end. E stands for equation. So remember, we have a handy dandy conversion chart. I'm going to find mine here. We have our conversion factors, right? This thing. And then on the inside, these equations are going to be your friends, right? So you don't have to memorize any equations that we use in class. You can just go straight to our handy dandy reference folder and figure out what equation am I trying to solve for in this case, which one is appropriate for the question that I'm trying to answer, or are there multiple equations that I need to use in order to get to the correct answer? So you'll list those out. The first S stands for setup, move my face. So you're going to take the equation that you identified earlier and then plug in the given measurements from step number 1. So you're basically showing your work at this point. And you'll be able to identify, do I need to convert my units so that I can have a successful answer in the end? Like, do I need to convert seconds to minutes? Or do I need to convert miles to feet in order to properly have a solution at the end? Okay. You won't always have to do that, but that might be a good place to put it. And then the last step, let's get all that stuff out of the way, is solve. So when you solve your equation, you're obviously listing your answer, but you need to make sure that you include your final units in your solution. That is a big thing that people forget to do. And that's why I mentioned it up above here in the unknown. When we're trying to figure out that final unit early on, it makes it a lot easier in the end. So let's do a couple sample problems here so we can see what it looks like. So I have written out the guess method to begin with, or you could just simply place, some lines on your page to represent each of our letters, each of our 5 letters. You'll go through and identify each step. So here's our problem. You arrive in my class 45 seconds after leaving math, which is 90 meters away. How fast did you travel? As I look at my word problem here, I know I'm going to see some numbers right away, and these are going to be my given measurements, right? They're going to be associated directly to some specific variable, and that is my job to identify this. So these are all problems that go with speed, but we're going to eventually get to the point where we are talking about speed and acceleration, and then maybe some mass weight, gravity units come in, or some energy information. So we'll be getting to know several different types of variables, and that's when it's really important to use the guess method so we know what we started with and what we're trying to solve for when there's many different equations in play. Okay, back to the problem. You arrive at my class 45 seconds after leaving math. So my first thing right here is, what am I identifying with 45 seconds? Well, I know my unit is seconds, and seconds is a unit of time. So my variable here is time, which is equal to 45 seconds. Okay. My second one down here talks about 90 meters away, right? So if I look at my unit, meters is a distance unit. So I know I'm dealing with distance, which is equal to 90 meters. So as I fill out my given, t equals 45 seconds, distance equals 90 meters. Again, I'm including my units here, right? If I just leave those blank, sometimes it's confusing, or it might be easily, I might easily mix up what I plug into my equation. So including the variable, unit, and the actual measurement. U stands for unknown. What am I trying to solve for in this problem? Well, how fast did you travel? So fast is related to speed, or velocity in our case, or the variable v. So we're going to solve for v. And then it's also my goal in this unknown column to identify what is the final unit that I might end up with. So I know I'm going to have velocity or speed, and I know I'm working with meters and seconds. So most likely my final unit will be meters per second, because that is a very common speed unit, right? Next, identify the equation. So again, I'm going to take my handy dandy equation sheet. We're working in chapter 4 right now, so we're looking at speed. I know it's teeny for you to see, but you have your own at home, so you can look at it. Also from our notes from the other day, you have all those equations written down, I sure hope. But speed or velocity is going to be equal to distance divided by time. I like to teach it this way with our triangles. So I'm going to try and make this work. But if you cover up, we're trying to solve for speed over here. So if you cover that up, you see that distance is on top of time. Those other two variables are left over. So that's one way of identifying how that equation functions. So if you cover up the variable that is your unknown, your final two units will be there. So you can figure out what your equation is. Anyway, speed is equal to distance divided by time. I'm plugging that in and laying it out. My first S is setup, so I'm going to plug in my distance to there, and I'm going to plug in my time to here. So my equation will look something like this, right? 90 divided by 45. And then my final S is solve, and I'm going to go through and calculate that out. 90 divided by 45, those of us that can do it in our heads, hopefully you're all saying 2 meters per second, and I'm including the unit over there, right? So that's my final solution. Again, I know some of you are like, well, I could just plug it in and get the answer. Don't make me go through all these extra steps, Miss P. Well, you know what? These extra steps will benefit you in the long run, I promise. Especially if you're somebody who likes to go really fast or may not pay attention to the original equations. This is actually spending 1 more minute completing this chart eliminates a lot of unnecessary errors. So, next problem. How far can you get away from your little brother with the squirt gun filled with paint if you can travel at 3 meters per second and you have 15 seconds before he sees you? I wanted to pick a random, interesting problem here, right? So pretend that's my son with his squirt gun filled with paint and we got to run. So I'm going to identify here a couple variables right away. I know I see 3 meters per second. Meters per second is the unit. So that's a distance divided by time unit. So that mixed unit is going to be our speed that we're traveling at as we run away. And then over here, you have 15 seconds before he sees you. Seconds is our time unit. So our variable t is going to be 15, right? So I've laid out my givens with the value and the unit. My unknown right here at the top, how far? So I know I'm going to be traveling a distance. And how did I get meters? If I look at my units over here, right, I know seconds are related to time. M must be my distance unit. So that's why I know I'm going to end up with something in meters. Question mark, meters. Using my chart here, if I cover up distance, I'm going to put my little pointer over the top of it, right? So distance is over here. Then I'm left with speed and time at the bottom. So I'm going to multiply those across with each other. So distance is equal to speed times time, which is my equation. I can plug in for setup. The 3 meters per second is my V. 15 seconds is my time. These seconds will cancel out, which is how I'm left with meters in the end. So those will go bye-bye. And 3 times 15 is equal to 45 meters. Hopefully that makes sense, okay? Now I'm just going to take this problem and change one little piece to it. So we know we're carrying over the same information, so I left distance and I left the equation, but this time we have some different information. I changed the time. And some of our problems are going to require us to do some unit conversions and use dimensional analysis. Why would it ever be written this way? It most likely won't, right? Writing something in 0.005 hours is ridiculous, but I just wanted to take something that we're familiar with already and then just kind of give you a little look-see at what it would be if you use dimensional analysis. Okay. So same speed, 3 meters per second. Now my time is in hours. Why can't I just leave it that way? Because my speed is meters per second. Those time units are not going to nicely cancel out with each other. So I need to make sure I convert my hours to seconds in order to fit this unit over here. Hopefully that makes sense for you. So I've laid out my givens. I know that's there. I need to change my time. So I'm going to use dimensional analysis. And here's my little setup. I know I'm starting with 0.005 hours. So I'm going to put that in the top window of my dimensional analysis track. In my next set of windows, I'm going to identify, hey, hours is the unit that I'm starting with. So that means hours is going to go in the opposite box down below. I can go hours to minutes, which is my next little transition or conversion factor. So I know for every 1 hour, there are 60 minutes. Okay, and then from there, I can go from minutes to seconds. Again, minutes is up top. I want to cancel that out, so I'm going to put minutes in the bottom and convert to seconds, which is going to go up top there. 1 minute, there's 60 seconds. So my new time, like in our previous problem, is now 15 seconds. So that makes me happy because then I can go back through and take these and they can cancel out easily instead of using hours. So same sort of setup and solve. So the additional dimensional analysis would be required if you have some mixed time units that don't align properly, or your distance doesn't align with your speed units, that sort of thing. One more, because I did one for distance, I did one for speed, and now we're going to do the remaining variable. In a competition, an athlete threw a flying disc 139 meters through the air. While in flight, the disk traveled at an average speed of 13 meters per second. How long did the disk remain in the air? All right, identifying my givens. Again, reading through. I knew he threw a disc, or she threw a disc 139 meters. Meters is a distance unit, so I know 139 meters equals D. And then I'm looking at the disc traveled at an average speed of 13 meters per second. A lot of our problems are going to state right before them which variable we're working with. So speed is V, which is going to be equal to 13 meters per second. The unknown, how long did it remain in the air? So how long, that's going to be our time unit. And then identifying that we're most likely going to be using seconds as our time unit in the end when we solve the equation that I need to use. Again, here's my triangle. I'm going to cover up time, let that thing disappear. Distance is up top divided by speed, so that's how I know my setup. Okay. Then I'm going to set it up and plug in my variables to my equation. And then again, my meters will cancel out because one's in the numerator, one's in the denominator, and I'll be left with seconds in the end. And that should be 10.7 seconds. And you can double check my math on that one. So there are sample problems using the guess method. You don't have to write out all the letters if you don't want to, but it's nice to have them organized so you know what variables you are given in the problem and you're using the correct equation. You plug them in properly and you actually have a correct unit in the end. Good luck with your practice problem.